Thanks for joining me again. We are continuing our discussion of quadratic equations, and in this video we will talk about solving a quadratic equation using factoring. Now, the important thing is that in this video, unlike a previous one, we will look at cases where the coefficient of the x squared term, a, does not necessarily equal 1. So if you haven't had a chance to look at the playlist of quadratic equations, please check it out. There is another video for factoring quadratic equations that have a equals 1. That's a simpler case, and I really recommend viewing that before going on to this video, which is a little bit more general. In the case of a equals 1, we looked at factors of this form, and we found that Q and P, right, Q times P has to be equal to our C in our equation. We found that by multiplying out these parentheses. So that is what we did in that video, and here we're going to do something similar, but it's going to have, there are going to be more terms because a does not equal 1 necessarily. So it's going to be a little bit more complicated. So if we look at the form here, you see what we have is we have two linear terms. These are going to be the factors of the quadratic equation. We have the Q and P that are similar to the ones we had in the other video where a equals 1. But we also have coefficients for our x's. Why is that? Well, because we have a not equals to 1. And when we multiply these, we have to make sure that we can get a solution that is not 1. When we multiply these using the distributive property, and we can go slowly, we take the first term, which is dx times fx. Okay, so we have d times x times f times x. We have a second term from d times x times p, and we have a third term plus q times f times x, and finally we have the last term, which is q times p. Okay, so now the important thing is that, again, if we want this side to be equal to this side, all the terms have to be equal. And so q times p has to equal c, and here we have d times f times x squared. So d times f has to equal a. And then we have these middle terms, which are mixed with coefficients and a linear, a 1 power term of x. So the important thing is, though, that we learn from here is that, similar to the other case, q and p are factors of c, just like in the previous case. While d and f, because their product equals a, are factors of a. So you can understand that what we'll have to look at is both factors of c, like previously, and factors of a, and in order to find this form and try it out for the different possible factorizations. So this was a lot of words, but let's get started with one simple example. Use this to clarify how we use this method. So our example is 2x squared plus 7x plus 3 equals 0. So our a here is 2, right? And our c here is 3. And our mixed term here, the middle term, b equals 7, right? So we indeed have a case where a does not equal 1. So we do have to look at the factors of a. This is a simple example. And the factors of a are just 1 and 2, right? There's nothing, no other factors. The factors of c are similarly simple. We have c equals 3, so a equals 2 and c equals 3. And so our factors are 1 and 3. Now, we have to look at various combinations, but we'll start with this simple one. What does this mean? It means we're taking two factors where d here equals 1, right? And f equals 2. So this is d and this is f. And this is Q and this is P, right? As you can see from this expression here. So what do we get? We get 1 times x plus 1, right? That was dx and q, times 2 times x plus 3. So this is a possible factorization. And if you multiply this, these parentheses, you'll see we do get 2x squared. We get x times 3, so that's plus 3x. We get 1 plus 2 times 2x, so that's plus 2x. And we get 1 times 3, which is 3. So our first term and our last term are correct. What about our middle term? Our middle term is 5x. Okay, 5x is not 7x, right? So it's not correct. So this is not the correct factorization. Let's look at another option. The other option is to continue with 1, 2, but now to switch the order of Q and P. So basically to write that Q equals 3 and P equals 1. In this case, similarly, we have 1 times x plus 3, right, because now our Q is 3, times 2x plus 1. Okay. What does that look like? Well, again, we get, from the first term, we get 2x squared, x times 2x. Then we get x times 1, so that's plus x. Then we get 3 times 2x, which is 6x. And finally, we get 3 times 1, which is 3. So the first and the last terms are correct, and our middle term is 7x. Now, 7x is exactly what we have here, right? So this is our correct factoring. And so essentially we found the answer. I just want to go one further step and show you that we don't have to look at more options in this case. Let's imagine that we switch the order of the factors of A, and we take 2, 1 with 1, 3, okay? So we're taking this first option here, but we're switching the 1 for A. In that case, we get 2x plus 1 times x plus 3, right? So 2 is our D, so we get 2x, then 1 for our Q, 1 for our x here, and 3 for our P, right? Now, if we look at this, this is exactly the same as this factorization. We just changed the order. So a general rule here is that we only have to change the order of one set of factors. So if we keep the A factors in one order, we have to look at both options for the C. But if we keep C in the same order, we have to switch the one for the A. And that is true even if we have more factors than just 1 and 2 or 1 and 3, even in the most general case. So again, what we found here is that 2x squared plus 7x plus 3 is equal to x plus 3 times 2x plus 1. Okay? And both of these are equal to 0. So now we have a factored equation that we can solve. Now, how do we solve this? Again, this is a review of something we spoke about earlier. If we have a factored form for an equation, we use the zero product property, which basically means that if one number, A1 times A2 equals 0, then either A1 equals 0 or A2 equals 0 or both. So in our case, that would mean either x plus 3 equals 0 or 2x plus 1 equals 0. Now, the nice thing about this is that it's easy to solve these linear equations. We can subtract 3 from both sides and get x equals -3. And here we have a slightly more difficult equation, but we can subtract 1 and then divide by 2 so that our solutions are x equals -3 and it's not or, and negative half. So those are the solutions to this equation based on the factoring method. Now we're going to go one step further and look at another example where some of our coefficients are negative, because in that case we have to be, again, just a little bit more careful, but again, we don't have to guess anything. So let's look at the case 2x squared. So again, we have an a that's different from 1. Minus x minus 15 equals 0. So in this case, our a equals 2, our c equals negative 15, and our b equals negative 1. So we do have an a that is not equal to 1, but we now have a c that is a negative number as well as the b. And so when we have a c that is a negative number, we have to find a product of two numbers where one is positive and the other is negative, so that we get the negative number. Okay, so again, we're looking for a situation like this, right? dx plus q times fx plus p. So we're going to look for factors of a and factors of c. So for a, again, a equals 2, so the factors are just 1 and 2. For c, it's a little bit more complicated. Our factors are, for minus 15, the factors are 1, 3, 5, and 15, but with both signs. So we can have either negative or positive values. Now, if you look at this equation, you see the coefficient, the middle coefficient is just 1. And so that might hint to the fact that this factor, 15, either plus or minus, is probably not going to be helpful. We may have to check it out, but it seems smarter to start with these coefficients, okay? So in this case, c equals negative 15, and the first pair we'll look at, say, are 3 and negative 5. So again, we have to take a negative and a positive because the product has to equal negative 15. What does this mean? So again, looking back at this form, the possible factorization is we take our d from here. This is d, right? So it's 1 times x plus our q, which is our 3 here. That's q, so 3, times 2x minus 5. So this is one possible factorization, and we have to multiply and open to see if this is correct. So if we multiply our first term by the other first term, we get 2x squared. The second term is 1x times negative 5, so that's negative 5x. The third term is plus 3 times 2x, that's 6x. And then finally, we have 3 times negative 5, which is just minus 15. So again, our c term and our a term are okay, and we get here plus 1x. Plus 1x is not negative x, so that's not the correct option. Okay, let's try to switch the order. Okay, we have 1 and 2. We can switch the order, minus 5 and 3. Okay, let's try that out. So again, we have 1 times x minus 5. Then we have 2 times x plus 3. What do we get? Again, we get 2x squared from multiplying the first by the first. Then we multiply the first by the second, so we get 3x. We multiply the second by the first, so that's minus 10x. And then finally, we get minus 5 times 3, which is minus 15. Again, our a and our c are correct, but our b here is negative 7x, which is not correct. So that did not work. Let's go on. We have 1, 2. Now, what we can do is we can go back to these two numbers, but just switch the sign. So let's write it as minus 3 and positive 5. Okay, so we took this first version, but we changed the signs. What did we get in this case? So again, we have 1 for our d, so that's x, negative 3 for our q, times positive 2 for our x, and positive 5 for RP. Now let's multiply. Again, we get 2x squared. I wrote here minus q instead of minus 3. So we have 2x squared. Then we get 5x from our first multiplication, right? Then we get negative 6x from our second. And finally, we get negative 15. And in this case, our A and C are correct. And we also have minus x here. So this is the correct factorization. We may have had to go further to check also plus 5 and negative 3. These are not equivalent because we're keeping this order, okay? But we don't have to switch the order of 1 and 2 as long as we look at all the options for 5 and 3 and then all the options for 15 and 1. Now we could go on and check 15 and 1 with all the negatives and positives in order, but there's no point because we did find a good solution. Let's highlight that in a different color and let's write it out here. So we know that ax squared minus x minus 15 is equal to x minus 3 times 2x plus 5. And this, we know, is equal to 0. So now again, we can go ahead and solve using the zero product property, which is the reason we factor all our polynomials. And we can say that either x minus 3 is equal to 0 or 2x plus 5 equals 0. Here we add 3 and we get x equals 3. And here we can subtract 5 and get 2x equals negative 5. And if we divide by 2, we get x equals negative 5/2. And so our solutions are, we sometimes write them as x12 equals 3 and negative 5/2. So that was another example where the coefficient c had a negative sign, and therefore we had to look at two different signs for our factors. There could be a case where b is negative and c is positive, in which case we're looking at both q and p negative. So their product is positive, but when we add them up with our coefficients of a, we get a negative b. So thanks for joining me again. If this was helpful, please press that like button. Please do check out the rest of the playlist for quadratic equations, and thanks for joining me.